Thank you for attending our digital conference series. I have John Norwood with me today to speak about his very interesting company that is developing end-to-end solutions for indoor farms that are interested in using their waste to generate energy as well as hydroponic nutrient solutions. My name is Javid Abraham. I'm lead systems design for agriculture. We design and advise on indoor farms globally. And today, John is going to share with us his exciting technology.
Hi, how you going? It's very nice to be speaking with you today and presenting this webinar. My name's John Norwood from Enesys. We operate a engineering consulting and research and design business in Australia, Victoria. And in recent years, we've focused a lot on sustainable energy systems development.
Excellent. So your company is focused on energy solutions and waste solutions for indoor farms, correct?
That's right. We're not trying to limit ourselves to any particular technologies. We're creating infrastructure for lots of industries to join into so that they can recycle all their waste resources and become useful resources. This is about the one-wayness of existing infrastructure that doesn't allow anybody to feed back into society, where if we can put industries on a platform where they're interconnected, we can create all those circular economies that don't exist.
Perfect. And how long have you guys been working on this?
We've been doing it for about 15 years and or more. And a lot of that came together with putting together systems to join and link. But then we started marketing pretty hard to say, look, we can do things better. And what we found 15 years ago, and it was our mistake, is that we tried to change the way industries do their thing. So we tried to say to a grower, hey, you should have an energy front end, and they'd say, hey, buddy, I know about basil, but I don't know anything about energy or digestion or gasification, whatever it is. We're not interested. And it wasn't just the grower, it was the financiers and the insurance companies and everyone else. And we'd say the same thing to energy people and say, hey, you've got all this carbon dioxide, heat and water going on. You really should be growing something. And they'd say, you nuts. So we spent a lot of time trying to convince them to change their stripes. And now we've realized that that's not the right approach. The right approach is to create an environment where they can all sit in the environment and not change their business model too much. It's just that they're now sitting on pipe work that recycles resources.
That's very interesting. I'd love to hear more about it. So without further ado, I'd like to ask you to present the slides you've prepared for this section, and we can hear a bit more about what your company does in detail.
My name is John Norwood. I'm the founding CEO of Enesys, which is a research and development and engineering design and construction company based in Victoria, Australia. And I'm pleased to be able to present this agricultural webinar. Amongst all the great growing innovations in protected cropping, greenhousing and indoor farming, there's a giant barrier that prevents practical and economic application of those technologies. Energy demand. That's energy demand. And that is where the starry-eyed plant physiology students and professors and industry experts stop their presentations. Yes, growing technology is great, but it's not economic because the energy costs are dramatic. Who's talking about energy solutions? If you want to feed the masses, don't rush to install vertical farms and LED lights in vacant city buildings because the conventional energy need to grow the crop and maintain temperature and humidity limits the farm to only the highest value products, not staple vegetables. Energy costs limit the growth of indoor farming or vertical farming industries to boutique crops, herbs and microgreens, and novel commercial investments that demonstrate growing concepts, not economics. We are only going to flavour our food, not feed the masses. Even if energy costs to grow staple vegetables indoors were economic, the fossil fuel footprint of most power supply grids is large, and mostly intangible ecological costs that increasingly are not sustainable. Throughout Australian states and territories, coal, gas and oil contributes between 75 and 85% of all electrical energy. We don't have a lot of time, so accepting that traditional farming, energy generation and waste disposal and all the associated distribution systems are unsustainable, how do we go forward where high density human populations require high density stable production? Since the Industrial Revolution, our leaders have built massive supply and demand chains with community and national infrastructures that are only one way, from top to bottom, where large government and multinational corporations control the downwards flow of products to businesses and people who are called consumers or users. Take time to think about the physical one-wayness of our massively built economies, spanning between states, countries, and continents. I've never liked to be called a consumer or a user, but here we are. Most of us are willing to put back if we could, but there's no community or national infrastructure or grid to put back anything. No wonder we find it hard to practically or economically recycle anything. Growing is an industry that can put back. Photosynthesis is nature's most powerful recycler of low-value products to high-value products. Add light and warmth to a seed with carbon dioxide, water and nutrients, and we magically end up with a high-value food, fuel, or building material. That's what Enesys does. Enesys creates physical infrastructure to link businesses where growers can be part of a wider and sustainable circular economy that also includes waste recycling, energy production, and many other resource-sharing industries. We call this GrowLink. How powerful is photosynthesis? I'm a fan. From a 1 gram seed to a forest giant containing 15,000 kilograms of carbon, guess where the carbon came from? A scale up of 150 million times. I'll take a breath and say that again. 1 gram to 150,000 grams of carbon. That's a good upscale. Check out the GrowLink symbols on these natural cycles. GrowLink can recycle the decaying products of landfill and mulching, methane, water, and carbon dioxide, and it can recycle waste heat, water, and carbon dioxide from power generation. GrowLink can also recycle all the nutrients within that loop. Back to me. My life as a teenager was shaped by my father's contracting business that cleared land, built roads and dams, installed power lines, and constructed buildings for farmers. Our patch included the largest power generation region in Australia. The Latrobe Valley brown coal-based energy provides over 4.5 gigawatts, which is about 25% of the baseload energy capacity feeding Australia's national grid. These coal-munching machines are longer and taller than a football stadium, and open-cut mines are deeper than sea level. I'm no stranger to the detrimental effects of coal and physically enormous open-cut mines in Latrobe Valley. They make fracking seem like an itch, but that's another story. Naturally, I became an engineer wanting to change the way the world works. How do we do it? We're engineers. You can switch off for a bit here. Throughout my employment with large industrial design and construction companies, engineering consultancies, and my own business that started in 1988, I specialised in process control. Industrial process control is about linking large and complex systems so they can work harmoniously as a whole, and automatically managed with a high degree of security. We have designed and constructed all types of complex control systems. Enesys supplies the same process control technologies and systems that are normally found in heavy industry, power generation, petrochemical plants, and manufacturing to create sustainable energy and growing systems. Back to growing. Remember the natural cycles linking growing, photosynthesis with decay and energy, combustion, energy. The dotted red and yellow links are the key to feeding our expanding populations, and we have to find a sustainable energy source for growers, especially indoor vertical growers who don't have any sun. Luckily and quite naturally, a grower is an ideal partner for an energy generator because all of the undesirable waste products of energy generation are desirable for plant growth. In simplistic terms, a vertical farm energy system may look like this, but the system can be any growing building type in any country, any season. We call this a WEG system, W-E-G, waste to energy to growing. And the recycled waste can be any discarded vegetable, animal, or manufactured organic material. It could also be an EBWEG system, M being municipal waste to energy to growing, or a BWEG system, brewery waste to energy to growing, or an SWEG, supermarket waste to energy to growing. You get the drift. Mm-hmm. There are endless sources of organic waste, and as discarded waste, there are economic and ecological problems, but not for a grower who's part of a WEG economy. The grower could just be a grower with no waste or energy expertise on a site that has a WEG backbone and waste recycler and an energy generator, and other businesses that are all part of Sustainable Village, or whatever you want to call it, like this one. There are no one-way grids here. If a business can't put back into the WEG economy, they probably shouldn't be there. Or maybe that's also a sign that they should look seriously at their business model. You may ask, what is the ecological consequence of vertical farming powered from national grid? Luckily, we've built a few carbon footprint models of typical domestic food supply chains called 10 grams of basil for broadacre farming, for greenhouse growing, and for indoor vertical farming. This graphic result is for indoor vertical farms. It's too detailed for you to read, but you can see the various waste streams heading downwards to create methane and carbon dioxide clouds. The size of the clouds are proportional to the size of the effective carbon dioxide emissions. In short, if a human eats 10 grams of basil, the result for an indoor vertical farm are: 1, the grower had to grow 30 grams of basil. That's fair enough, because we're wasteful. 2, the carbon contribution clouds of all the decaying organic waste streams add up to about 9 grams of effective carbon dioxide. Other transport and agricultural contributions total about 4 grams of effective carbon dioxide. Here's the big one, the large brown cloud at the top. In the vertical farm if the vertical farm energy is supplied from a typical national supply grid, it will contribute an additional 260 grams of effective carbon dioxide to the atmosphere.
Wow.
Just for 10 grams of basil. So ecologically speaking, it's telling us that we really shouldn't replace the sun with grid-based energy. It also tells us to install sustainable energy systems to power vertical farms. And now we're back to WEG. So where does all the waste or surplus resources for WEG come from? Ideally, one or more of the Sustainable Village partners creates a steady supply of suitable organic wastes, including growers, brewers, milking sheds, chicken farms, packages, and abattoirs. Additionally, organic waste that are already collected can be delivered or diverted to WEG systems, including municipal, industrial, and agricultural materials. Enesys supports the development of high-density urban growing, and GrowLink enables waste to energy to growing WEG systems that can reverse the detrimental environmental effects of conventional energy production, waste management, and growing systems. Thank you for watching. Here is our website and all our links for you to follow our journey. We're building a waste to energy growing precinct in Victoria this year. We'll be beginning that process. And we're also available to consult on any energy requirements or alternative energy solutions that you may have in agriculture. Thanks to the team at Agritecture for this opportunity. I'm open to any questions you might have. Thank you.
Thank you very much, John. That was extremely interesting and very thorough. I really like that graphic that you had quantifying the carbon footprint of 10 grams of basil. I was very surprised to see the carbon footprint of just 10 grams of basil. If I understood it correctly, it was 258 grams of carbon dioxide for every 10 grams of basil grown in a traditional or indoor farm. Is that correct?
That's exactly right. The fossil fuel cost is massive.
Wow.
And people don't respect the usefulness of the sun's energy. It's just fabulous. And for us to replicate that by digging up fossil fuels is dramatically wrong.
Yeah, well, I guess those fossil fuels were created by the sun at some point, many millions of years ago. But I couldn't agree more that trying to recreate the sun in many situations does not really make a whole lot of sense. And it's part of the reason why at Agritecture, we often encourage our clients to look at greenhouse models instead of going directly for vertical farming systems that are lit by sole source LEDs, because there are significant opportunities in reducing operational costs when when it comes to selecting your illumination method. And there's really, there are a few better methods out there to light your crop canopy than using natural sunlight. LEDs are certainly getting better, but as you mentioned multiple times, that the energy solutions there to power those LEDs are not at a point where they create a sustainable closed loop cycle like the ones that your company is providing the industry. So I have a couple questions for you related to what you guys are doing and the technologies you're integrating. And one of them is, why are you focusing on growers? What is it about the indoor farming industry and maybe even outdoor farming industry that is attractive to your company? And how can growers kind of adapt these policies and methods to make their operations more sustainable?
If we look generally at trying to recycle waste and create energy, which is a fabulous thing to do, we're always looking for the best possible partner to use the energy or resources that we get from that. And it just turns out that a grower, and especially an indoor grower, where they need lighting energy and heating and cooling energy all at the same time, is a perfect partner for cogeneration. And if we're converting a waste to energy, we've got electrical energy, we've got carbon dioxide, we've got heat, we've got water, and it's all happening at the same time. And that's exactly what the grower needs. If we tried to apply that to a hotel chain, they might need electricity at a different time, they need heating or cooling, and that doesn't work out so well. So a grower is a perfect partner for this kind of operation.
That's very interesting, that the kind of synergies of what the technology provides and what growers need match up so nicely. I guess it relies on engineers like yourselves to design those systems where the quantities of inputs match the needs of those growers, and there is that synergistic balance between those two systems. So given the high energy costs of the indoor farming systems on the market, how does your company rise to meet those needs in differing markets where there may not be the same resource available, or there may not be the same demand for these types of outputs, namely energy and digestate that comes out of some of the systems that growers may use as a nutrient solution?
Well, again, there are a lot of mistakes can be made in this industry, and one is to think that you've got a good, reliable supply of waste as a resource. And give an example, if now we were relying on restaurant waste, we'd be in trouble because of our current situation.
Yes.
So we've changed our model to say, hey, within our precinct, we need partners who produce waste. So we don't have to look for it. It's not part of some supply chain. We don't have to, for instance, if we said, oh, look, we're taking in municipal waste, it might be that we have to compete for that waste every year with a contract with councils. And that may not be all that good. So we've decided we need to partner with people like food processing people, or abattoirs or brewers, or companies that have an absolute waste issue. In that way, we've got guaranteed supply on the same side, and it's in our interest to share that resource. We don't have to compete for it.
That's interesting. So you look for large volumes of waste first, and then what you can do with that waste. That's fascinating that it begins with that waste volume. So in the context of the future of this industry, how do you envision your service growing and serving this industry in a large scale as the number of indoor farms multiplies, the size of the farms grow, and the indoor farming industry as a whole comes to the supply or the demand for these products in global metropolitan markets?
Well, I think in the future, I think it is driven by the need for urban populations to be able to feed themselves. I think we don't have to talk too much about broadacre farming and power generation the way it is. We know it's not sustainable. So it has to happen this way. We have to grow high density food in high density population areas. requiring this kind of energy support system. I do think that we have to set aside the one-way infrastructure that we have and create new precincts. Unfortunately, we kind of have to start again and start creating satellite sustainable precincts where we've got industries, growers, and waste collection, where communities can grow their own food, they can treat their own waste, and they can make their own energy. So I think it's going to happen in a satellite way, where increasingly the national infrastructure will be less relevant.
Yeah, and we're already seeing on some projects, some municipalities having issues with the volumes of wastewater that they can handle. It's very common in ag regions. And some of these operations are looking to process their waste on site in order to kind of relieve that load. So in our work, we definitely see the demand for this type of service, and hope in the near future that there will be more of these integrated into these farms as companies like yours grow to meet that demand. So we are coming to a close in this section. I'd like to thank you very much, John, for joining us for this exciting series on various technologies and companies that are rising to meet the demands of this industry. Do you have any websites or resources that our viewers can access more information on your company?
Yes, we do. Our main site, www.enesys.com.au is our main site, and it leads into just about everything that we need to link to, and we're fairly active on Facebook and LinkedIn, so you can follow our progress with our new waste to energy growing demonstration process in Victoria.
Oh, excellent. That's perfect. I'm actually very interested in looking at that myself, and I'm sure our followers will be interested in seeing that too. Well, thank you very much for your time today, and thank you for joining us on this series. Do you have any closing remarks you'd like to add to the closing?
No, I think I would say that I'm very positive about where we can go with this. It's we're not filling in some gap. We believe that we can make a difference, and we have to make a difference. So we're into the essence of the whole industry.
That's very exciting. Thank you very much, John. We really appreciate your presentation and all the helpful information you provided us about your company. I'm very excited to see you guys grow, and look forward to meeting you at some industry conferences, perhaps.
You're welcome. That'd be great.
Thanks, John. Take care.
Thank you. Okay. Bye-bye.